Finding z-scores from known areas. All previous examples involved a standard normal distribution, and they were all given a z-score and followed by finding the area or probability. Sometimes we will need to reverse this method, meaning that we are given a known area or probability and then finding the corresponding z-score. It is very important to avoid confusion between z-scores and areas. Remember that z-scores are distances that are along the horizontal scale, but the areas or probabilities are regions that are under the density curve. Now, table A2 lists the z-scores in the left column and across the top row, but areas that are found are in the body of the table. Now, also remember that z-scores positioned in the left half of the curve are always negative, and z-scores in the right half of the curve are always positive. So if we are given a probability area and want to find the corresponding z-score, we will use the following procedure. The procedure for finding a z-score from a known area or probability. Number one, always draw a bell-shaped curve and identify the region under the curve that corresponds to the given probability. If that region is not a cumulative region from the left, work instead with a known region that is a cumulative region from the left. Number two, you're going to use table A2 or technology to find the z-score. With table A2, you use the cumulative area from the left, locate the closest probability in the body of the table, and then identify the corresponding z-score. Let's try an example here. Example 6, bone density test, finding a z-score using table A2. Now, scores of a bone density test are normally distributed with a mean of 0 and a standard deviation of 1, so they meet the requirements of a standard normal distribution. Find the bone density score corresponding to the 95th percentile, and what that means is find the bone density score that separates the bottom 95% from the top 5%. So, the first thing we want to do is to draw a bell-shaped curve and identify the region under the curve that corresponds to 95%, which is equal to 95.95. Now the next step is that if that region is not a cumulative region from the left, then work instead with a known region that is a cumulative region from the left. So let's go ahead and draw that bell curve. So you can draw the bell curve. Okay, and so we know that the mean is 0. And so what we want to do is we're going to draw a line, and then we can shade in what represents 95% or 0.95. So by shading in this entire piece here, we will see that that represents 0.9500. Okay, then you can see here that that represents 95%. Remember that we know that the area under the curve is a total of 1. So if we take 1 and then subtract 0.95, we're going to get that 0.05, which represents that 5%, which is the top 5%. So therefore, we can then say that this piece right here is going to represent the 5%. Okay, but now what we want to do is we want to be able to find what is that z-score that is associated with the area of 0.9500. So what we're going to have to do here when we're using the table is we want to search for the area of 0.9500 in the body of the table and then find the corresponding z-score. So let's look at the table here. So on the left, we have our negative z-scores. On the right, we have our positive z-scores. So if you take a look at the left here where the negative z-scores, these areas in the body of the table do not show anything close to 0.9500. But we can come over here on the right and we can see that the positive z-scores are going to show that area that might be close to what we're looking for. Keep in mind here that we're looking for this z-score on the right, which is to the right of 0. So we are going to be finding and looking for a positive z-score. That's why it's important to draw the picture so you know where the location of the z-score is going to be. So we're going to look for 0.9500. So if you look over here, we got 0.9495 and then we have 0.9505. Well, if you notice that in a table, we do not have the area of 0.9500. However, we find two areas that are above and below 0.9500. So if you take a look here, these two areas we know are in between, or 0.9500 are in between those. So if we take a look at those two areas, 0.9495 and then we have 0.9505, and we know that 0.9500 is in between them. Now, what we normally would do is we want to find out which is closer to that 0.9500. Well, if you notice, if we subtract 0.9505 with 0.9500, we will get 0.0005. And if we subtract 0.9500 with 0.9495, we also get 0.0005. Now, since they are both the same distance, what we have to do is we need to then find the average between those two z-scores. So let's go ahead and take a look at those two z-scores. So the first z-score, which is 1.64, and the other z-score is going to be 1.65. So what we're going to need to do is the following. We're going to need to find the average of those two. So again, the z-score associated with the area of 0.495 is 1.64, and the z-score associated with the area of 0.9505 is 1.65. So again, when this happens, we take the average of the two z-scores. So 1.64 plus 1.65 divided by 2 gives us the z-score of 1.645. So we can come back up here now and we can be confident to write what our z-score is going to be. And now we can say that that z-score is 1.645. So now we found that this is 1.645. So the z-score of 1.645 is going to separate the bottom 95% with the top 5%. So we can now conclude that the z-score is 1.645. So the 95th percentile is z, which is equal to 1.645. And then here's the interpretation. For bone density test scores, 95% of the scores are less than or equal to 1.645, and 5% of them are greater than or equal to 1.645.